Let's take a look at a wax melter for doing seals. And I wonder if it had other applications. It's not the out type seals. It is the ones that people put in the back of envelopes for some reason. So, oddly, on the front it says low voltage power supply is safer, and it makes me wonder, I thought this was just going to be a standard PTC heater in here, but technically speaking, maybe it is. Maybe they're using a low voltage power supply and a resistor and a thermistor and something like that to actually do it. So before we take it apart, we shall analyse it externally, because we'll be able to tell if it's got an electronic power supply in it by the fact that it will have a poor power factor. And we'll also be able to tell if it's just a straight PTC thermistor, because that will be a very high power factor, like 0.9, and we'll also see the power peak initially. So let's do that. Let's zoom down on the display a little bit. The super flickery display. Oh, you know what? I could turn the light off and then, hold on, I'll just set this up. 1 moment, please. That's better. So we've got 247 volts here, 50 hertz or so. So I'm going to plug it in. Nothing happens, but there's a button here, one of the sort of paw print type things. And it shot up to, wow, 300 watts, and now it's going down. Power factor is 0.9. This is no electronics, other than what's lighting the LED, which is shimmery, if I'm not mistaken. We'll find out. That may just be a resistor in series, the LED, and this bit here is now heating up. It's up to 40 watts. Well, it's down to 40 watts power. Tell you what then, watch your eyes, the light is coming back. The light is back. Look at the flicker now. Yeah, that's half wave driving that. It's probably just a resistor. Maybe if we're lucky it'll be a diode as well. So I'm going to get this little scoop and I'm going to use the completely wrong wax. I'm going to put in paraffin wax, and the reason I'm going to be using paraffin wax is simply to melt some wax, basically, and then get a thermocouple into it, and we'll check what temperature this goes up to in case it's got other uses. So I shall do that now. This could take a moment for it to stabilise, so I shall pause. 1 moment, please. Okay, I think that's long enough. It's hovering around about 150 degrees Celsius. Oh, can you see that? You can now. There is definite vapour coming off this wax, and the power has equalised at around about 18 watts. Now, the thermocouple is actually just being held at a sort of midpoint in the wax. It's not touching the metal case, but this thing is getting hot enough that I wonder if hot melt glue would be usable in it if you wanted to do something like that. I'm not sure what the wax composition of actual sealing wax is. It's kind of more like a modern, I'd guess the modern stuff is plastic. Right, I'm going to press this button and turn it off, and I'm going to let it get this wax out of the way first, and then we'll open it up. Right, 1 moment please. I think it should have cooled by now. I did another experiment just out of fun. I poured some Sal Ammoniac directly into here, initially in here and then into here, and I was trying to work out, is it a high enough temperature for it to actually create sublimate into a sort of, well, create that haze effect that Sal Ammoniac does. It's an old theatre effect, very hard to find information about it. In fact, looking online, the only information I could find was a video I made about it. But anyway, I did get a haze off it, but I didn't think this would be hot enough to do that. Anyway, it is not hot at all now. Let's grab a suitable screwdriver. Well, I say it's not hot at all. It does still have residual heat. Let's pop some screws out. I'm not sure which screws to take out, but we'll find out when I take some screws out. The Sal Ammoniac thing, or ammonium chloride, traditionally in the theatre entertainment industries, they used it as a haze generator. And what happened is that if you heated the powder up, it separated into two different gases that then reformed in the air above the haze pot, and it formed tiny little crystals in the air. Not good to breathe, really, but it produced a most excellent haze. So I was getting something off it. I don't know if it was just driving moisture out it, or if it was actually the desired haze. Certainly a laser in the air showed haziness. Oh, there we have it. So where is the resistor for the LED? Oh, it's probably, right, tell you what, let's dig that out. I notice it's kind of held in by hot melt glue, which has gone all soft and squishy. That's a surprise, I think it is. And there's a metal plate holding the PTC heating element onto the metal cup. And it looks as though it may actually be holding the metal cup in place too. Let's check this out. So, in case I haven't mentioned it before, a PTC heating element, positive temperature coefficient, is a resistor basically. And as it heats up, with the power flowing through it, it self-regulates. This is kind of stuck on, but not also stuck on. And the construction is simply a block of the ceramic and a metal plate on either side to allow it to move inside with expansion and contraction. And this is the only insulation. It's capped in tape as a sleeve slid over or wrapped around it and then just crimped with heat at one end. This does have a little insulating disc, a little silicone disc, possibly to help spread the heat. And also to, oh, look at the colour of these. Look at the discoloration of the plastic. That's a bit worrying. Can you see that? I'm not sure it's supposed to be that colour. I think it has been, the heat that's coupled along has basically started discolouring it. You would have thought it would discolour all this as well. So that little silicone pad's interesting. It will do two things. It's an extra layer of insulation, a very welcome extra layer of insulation. And also, it's going to help couple the heat onto this, between the resistor and the cup. But these resistors, they're commonly used. They basically, because they increase in resistance as they get hot, they self-regulate. They get to a nice equilibrium point. So there is the switch. Where is the component for where is the current limiter? Oh, jeez. The LED looks as though it's got the resistor mounted right up close. Right, tell you what, I'm going to try and get this LED out and we'll look at the value of that resistor. One moment, please. And resume with it almost back together. Other things worthy of note. The switch is held in place by the same things that are terminating onto it. The little wings that come out the side of this classic clicky switch are not just being used to screw it down, but also little terminals, little ring terminals are onto them. Right, tell you what, here's the schematic. It's not going to be very exciting. The most exciting thing is probably the temperature the whole system gets up to. Mains coming in, either polarity, it's not polarised. Blue is going through the switch. Black is going to the other connection. They've used blue and black as the colours. Through the switch, the LED is a standard red LED. It's not polarised. No other polarity protection. 220k resistor, which means that in one polarity, the current will flow through and make it light up. But in the other polarity, it will reach the breakdown voltage and the LED will probably conduct another half as well, but not light up. And this 220k resistor, it's effectively running the LED half wave, 1 milliamp, and this resistor will be dissipating power in both halves of the wave, so it's 260 milliwatt, which is okay-ish. It's a very small resistor. It's held in with hot melt glue with a very hot resistor. That's okay. And then it's just to the PTC heating element with its little metal strap holding on that silicon pad underneath. And that's the construction. I do not know why the box said, where is the box? Here it is. Low voltage power supply is safer. I think that's a warning. They say go and get a low voltage one because it will be safer than this. If you left this one on for a while, it might suffer thermal degradation because it does run at quite high temperature. I wonder what temperature the little empty dish runs at. I'll tell you what, I'll do an experiment. I'll put a thermocouple in touching directly onto that, and I'll also maybe put a little bit more Sal Ammoniac in, see just a few grains and see if it disappears, because that will be a clue if it is sublimating completely, if that's the correct word. What is it when a chemical breaks into two constituents that come off as a gas but then they recombine as a solid again? There must be, recrystallization comes to mind. There must be some scientific term for that. But there we have it. I shall do some more tests and I'll put the information in the description down below. In the meantime, I would say if you want to do hot seals, it'll work. Just treat it as a typical imported non-regulatory compliant piece of stuff. Don't leave it on too long because it will potentially suffer increased thermal degradation if it's left on, particularly with the heat spreading along this and putting these under stress. Although this is hard, it's that hard, brittle plastic by the feel of it. Let me scratch it. Let me do an Arduino versus Evil, an Ave. It feels quite hard and scratchy. It doesn't feel as chewy and plastic as usual. So it may be heat-proof-ish plastic, but don't trust it anyway. But there we have it. Very simple, nothing to do with low voltage whatsoever other than the utility industry definition of low voltage, which is 240 volts here. Very simple construction, and I suppose ultimately it does work. It could have other uses, maybe hot melt glue, maybe even some sort of polymorph type plastic could be put in, but it does have the potential. There's not super duper thermal regulations that may kind of overheat it. But interesting thing nonetheless.